So today we're going to work on combining functions. So we're actually going to talk about addition, subtraction, multiplication, division, um, composite functions, things like that. So all of this stuff is honestly a review from Algebra 2. I'm not going into anything deeper than Algebra 2 today. So we're going to review an entire chapter all in one day. Let's start with f plus g. If I'm doing that, all I need to do is x squared plus 2 plus 1 minus x. And combine my like terms. X squared minus x plus 3. That is f plus g. Any questions so far? All right, let's do f minus g. Now, when you do f minus g, it's slightly different. You want to put parentheses around the g, because that negative sign needs to get distributed. Kind of like that other problem we did earlier, the big long problem, where it was like subtracting something. A lot of you would forget to do that. So I'll have x squared plus x plus 1. That is f minus g. Now let's do f times g. X squared plus 2, 1 minus x. So I'm going to FOIL this together. X squared negative x cubed plus 2 minus 2x. And then I'm going to combine my like terms. So I've got negative x cubed plus x squared minus 2x plus 2. So far, okay. All of it looks familiar, right? None of it's new. Let's do f divided by g. So I'm going to put the f on top. I'm going to put the g on bottom. There's nothing I can do to simplify that. So that is f divided by g. That's it. Now, there is another part we need to do. We need to state the domain. Let's re-talk about that, because that was something a lot of you had trouble on the quiz with. When is the domain restricted? Raise your hand and tell me one time the domain is restricted. Mallory. Okay, if there's a square root, and if there is, what do I have to do with it? Greater than or equal to 0. Perfect. Square roots, I said greater than or equal to 0. What's the other time? X on the bottom, right? And I'll set it not equal to 0, because I can't have 0 on the bottom. Perfect. So, this first problem we did, the addition problem, right here. What's the domain? All real numbers. How about the second problem? What's it? How about the third problem? Hey, look. They're all real numbers so far, except for the division. So what do I need to do with that 1 minus x? Set it not equal to 0, and I'm going to solve that by subtracting 1. Negative x is not equal to negative 1. Divide by negative 1. X is not equal to 1. That's my domain. I can have any real number except the number 1. Any questions on this? Those all are familiar, right? Okay. So let's do some composite functions. So go ahead and take a second, copy that down. And after you write the two functions down, put the domain beside them. The domain of the top one. And what would the domain of the top one be? Perfect. Sarda, what's the domain of the bottom one? No, there's a square root sign. Remember, we just talked about square roots. That is if x is on the bottom of a fraction. So it has to be kind of. You're almost there, Cheyenne. Halfway. There you go. Greater than or equal to 0. Positive, but also equal to 0 would work. So, you do have a chapter test coming up next week. Okay, you have a chapter test, and domain will be on it next week. And it looks like it's something we need to continue to review, right? Okay, so let's find f of g. Now, if you ever talk to Mrs. Kilcoyne, she'll call that fog and gloss. I don't know why. But f of g, that actually means f of g of x. That means I'm going to take the g function and plug it in to the f function. So I'm going to take this function, and everywhere I see an x in the f function, I'm going to plug it in. So let's try that. I'm going to have the square root of x squared plus 2. Does that make sense how I got everything there? What is the square root of x squared? X. So I get x plus 2. But it also wants us to state the domain. And this is where it gets tricky. Okay? Right now, if I look at this, it looks like what? All real numbers, right? Immediately you're thinking all real numbers. But is the domain restricted above somewhere? Okay? That means I actually have to then relist that domain. X has to be greater than or equal to 0. Because those two functions are actually together, I have to give the most restrictive domain. So I'd like you to go ahead and try the g of f, and then we'll talk a little bit more.
How did you take the square root of x over 2?
So what I did was I took this one, and I plugged it into that x. So now you're going to go the opposite way. You're going to take the top function and plug it into the bottom function. So you're doing g of f. G of f of x. That means I'm going to plug the f function into the g function. So I get the square root of x squared plus 2. By the way, see how there's a plus sign? That means you can't take the square root of x squared. You cannot take them separately. Okay, so that is the answer. Okay, so you fixed a few things right there, and that may be a side note. Okay, you can't take the square root if there's a plus or a minus inside. So what do I need to do with that stuff in the square root? In order to find the domain, what do I need to do? Set it, you're close. Not equal, but greater. Perfect. So let's solve that. Subtract 2. X squared is greater than or equal to negative 2. Take the square. Uh-oh. Can I do this without getting the letter I? No. Okay. So it's not restricted at all this way, right? So what's the domain of this one? According to what we talked about in the last problem. Not undefined. Good guess, though. Well, remember if it's... So right now, this is considered all real numbers, right? Because this doesn't mess with it at all, does it? So it's all real numbers. But is it technically? Because of these up here, is it restricted up here? That means it's restricted down here. So our domain is x is greater than or equal to 0. Okay? If it's restricted above it all, it will then be restricted down in these functions. Okay? Let's find f of g of negative 5. F of g of negative 5. So all the rest of them said f of g of x, g of f of x. So notice my answer had the letter x in it, right? So I want to find f of g of negative 5. So what would I do? Go ahead. Tell me what you were thinking to do. That's all I need to know. So you were going to try to take the square root of negative 5 and then plug it up into the f function? That would work. That would work. But can you take the square root of negative 5?
No.
So can I do this? No. Okay. So Cheyenne did it one way and said, no, I can't do this. Cheyenne's right. So let's look at another way to do it. Have I already done f of g of x? Have I? I did it right here, didn't I? It's in blue. And it says that I could do x plus 2. Only if, though, what? X is greater than or equal to 0. Well, is that greater than or equal to 0? No. So this one is not possible. So Cheyenne, your way of doing it was perfectly fine. And notice that yours doesn't work because you can't take the square root of that negative. Hey, look down here. You can't take the square root of a negative. You can't do anything less than 0 here. On purpose, so that it would work that way. Okay? Good call. So here I'm given f of g of x is equal to the cube root of 8 minus x minus 5. Go ahead and write that all down. So we're looking for two different functions here. An f function and a g function. That if I do f of g, that this would come out. Any ideas? Any thoughts? What do you know about the f of g or g of f? Whitney? Okay, so she's saying I could use g of x as 8 minus x. Okay. Notice what she did was she took part of this function. And she actually just took everything underneath that cube root sign. Because the g of x function is the function I'm going to be plugging in, right? Okay. So Whitney, that works. There's actually another way to do it too, and I'll show that. But that works. So what would that make the f function? Huh. Well, let's check it. If I plug this in to this x, do I get that exact thing back? Yeah, I do. That works. That works. That's it. I took a small piece and made it the ending function, and I took the rest of it and made it the beginning function. Okay, so she replaced the 8 minus x with just the letter x. That won't work because, let's take a look at it. I like that, 8 minus x over 5. And then over here, what would you write? So what I'm doing is taking this whole thing and putting it into the cube root. So I'd get the cube root of 8 minus x over 5. So that one won't work. That was a good try, though. I like that. All right, so we found that doesn't work. What else could I do? Can I do anything else? I can. I can. Okay. How about I use the cubed root of 8 minus x? I'm going to use the whole top. And then what? Well, not 1 over 5, because if I use 1 over 5, x over 5, there you go. If I used 1 over 5, I had nothing to plug that into. But if I do x over 5, hey, that works also, doesn't it? Exactly. There's more than one way to do this, right? There is. So there's several ways, but what you have to do is make sure you test it. If I plug that in, it works, right? You've got to test it in your mind. Any questions? Okay, I need a question then. So what I had to do was come up with two separate functions. A small function, which we decided was 8 minus x, and then the rest of the function. So if I'm building around the 8 minus x, I still have the cube root. I still have the divide by 5. But I need to replace that function with something, so I'll replace it with the x. Okay. What I did was I pulled it apart and made it two separate functions. That's all I'm trying to do. I'm trying to make it two separate functions that then I can combine back to that. Because sometimes I'm not given here's F, here's G. Sometimes in a real life problem, I'm going to be given, hey, here's the two functions combined. So here's my two manufacturing companies combined. Can you tell me what company A is doing and what company B is doing, right? Okay, that way I know, do I need to eliminate some people or increase some people at one of those companies? So I need to break it apart to two different things. Okay? But there's more than one way to do it. That's the key thing. Okay? Any other questions? All right. Essential work. I'm done already. It's 11:12, which means you have about 20 minutes to get this done and ask questions. Use your time wisely.